Hello, boys and girls. It's Mrs. Lane here, and we are on lesson 25, Fractional Dimensions. If you're in the 2020 book, you're going to be on pages 262 and 263. Those of you who have the 2017 version are going to be on pages 254 and 255. So let's get started with the question in the tan box. A child's sandbox is 5 feet wide. Right there, we can see 5 feet wide. 4 feet long, and you can see the length, and 3 feet deep. So we know it's going to be 3 feet. Okay. Grace fills the sandbox so the sand is 2.5 feet deep. So if you had your sandbox here, and she fills it 2.5, which it shows this is 2.5. The sandbox would actually go up higher. Does that make sense? Do you understand that? Because the sandbox is, it's actually 3 feet deep. But she only fills it up to 2.5. So that's all we have to worry about. Okay? So what is the volume of sand in the sandbox? So boys and girls, don't let this question fool you. They make it seem harder than it actually is. You guys know how to find length times width times height. You know how to find volume. So all they've done is given you a fraction. They've thrown that fraction in there and trying to confuse you, but you guys can do this. It's simple enough. So what they've done is they've got 5, 4, and then they've got 2.5 here. They didn't draw whole blocks, but they just made half blocks. So let's go ahead to the next page. Page 263 or page 255, depending on which book you're in, and see if we can answer those questions. All right, ladies and gentlemen, here we are at the top of the page. It says, number 2, look at model it. How many cubes are in the bottom layer? Explain your reasoning. Okay, so if we take a look back at the page, at the model it, we can tell how many cubes are going to be in this bottom layer, can't we? Because we know that we have 5 of them lined up this way and that they are 4 deep. So how many total cubes are there going to be? 20. Good job. So your answer is 20 cubes. Please write that down. And then to explain yourself, you want to say there are 5 rows and each row has 4 cubes. There are 5 rows, and each row has 4 cubes. Okay, the second part of that asks, how many cubes are in the next layer? So if we go back and look at the model, we know that there are going to be 20 cubes in this bottom layer. When we go up to the second layer, how many cubes are there going to be? Did you say 20? Good job, because there's 20 in this layer as well. So how many cubes are in the next layer? 20 cubes. Okay, moving right along. How many whole cubes can you make with the blocks in the third layer? Explain. So how many whole cubes can we make? Well, to answer that, we ask ourselves, how many half cubes do we have? How many half cubes do we have, guys? Well, we have 5 times 4. We have 20 half cubes. And 20 half cubes makes how many whole cubes? Good job, you said 10. Let's write that sentence. There are 20 half cubes or 10 whole cubes. Okay, moving right along. Explain how to use your answers to problem 2 and 3 to find the total volume of sand. Okay, so all we're going to do for 2 and 3 is we're going to just add them up. So you add the number of whole cubes. Add the number of whole cubes. And when you add the number of whole cubes, you get what? Well, let's look. We've got 20 whole cubes, 20 whole cubes, and 10 whole cubes. What do we get? We get 50. So you add the number of whole cubes to get 50 whole cubes. All right, ladies and gentlemen, moving on to number 5. Use the formula volume equals length times width times height to find the volume of the sand. So volume equals length times width times height. If we go back to the model it, our length is 5 times our width, which is 4. Whoop, what am I doing? Which is 4 times our height, which is 2.5. And I'm going to write it like 2.5. Okay, so if you take 5 times 4 times 2.5, so we're going to write equals 5 times 4 times 2.5. Now, what is 5 times 4? 20. And what is 20 times 2.5? Most of you probably know that in your head, but if you don't, pause the video and figure that out real quickly. You should have gotten 50 cubic feet. All right, my fantasticos, let's do number 6. Number 6 says, describe how to find the volume of a rectangular prism when the dimensions include fractions. So when we've got a fraction, is it really that hard? Did the fraction mess us up or confuse us or change anything? Did it change our formula? I certainly hope you said no, because we didn't do anything different than we would normally do if it were whole numbers. So you use the same formula as when the dimensions are whole numbers. All right, boys and girls, good job completing fractional dimensions today. I would like you to go ahead and do the try it. There's 2 problems there that you can try. And then when you're done with that, you're going to move over to the PPS pages, 281 and 282. Great job, guys. See you tomorrow.